So in this problem, we are talking about a radioactive substance that has a decay rate denoted by K. We are given the half-life, which is 4,030 years, and we said we are asked to round to 6 decimal places as needed. Okay. So we know that the decay rate model, it will be given to you. It may not be given in these problems in MyMathLab. I don't care. I will give you the model. So each problem will have the model attached. So M0 e to negative KT. We are told that the half-life is 4030 years. That's all we need, and that's all we know. So if we start with an initial mass of radioactive substance, whatever it is, what happens in 4,030 years? Okay, so then it means that we have an ordered pair. So can anyone give us the ordered pair? Right, but remember the independent variable has to be first. First the independent variable in the first spot, and then the dependent variable. 4,030, comma. You just told me before we started. What happens in 4,030 years? Exactly. So 4030, M0 divided by 2. You just said that, right?
Yeah.
Right? Good. So we start with M0. We don't care what it is. But we know that in 4,030 years, we'll have half of M0. And this is the point we need to carefully put in the model. So I'm ready for the point. Right, the y value, of course, equals. Very good. That's it. So then 0.5 equals e to negative 4030k. Good. What do we do now?
Natural log 0.9 and natural log E.
He just came in. He barely caught his breath.
I had to put fire. Well, fire being Jack Pepper. Cheese.
Very good. Awesome. And whatever that is, I have no idea what it is. So this is natural log 0.5 divided by, in parentheses, negative 4030. And the answer is, careful, they want us to round up to 6 decimal places, right? That's what it says, 6 decimal places as needed, okay? So I'm going to copy this number as negative 1.719968 times 10 to negative 4. And remember, with negative 4, I have to move the decimal point 1, 2, 3, 4. So 2, 4, 6. 0.000124672. That's our K. So the model looks like this. Very good problem. Very nice. Thank you. E to negative 0.000172t. So for this, whatever radioactive substance that is, the model will be, what do we see here? Very good problem. Thank you. Questions?
Just a little confused at everything you just wrote in red.
Here?
Yeah, because I know I got the E to the -4, and it's because E is the natural log.
No. You got this, 1.71 e negative 4. This has nothing to do with e. This is the calculator saying 1.71 times 10 to negative 4. This has nothing to do with e. It's the power of 10. It's a very good question. I would have never thought of presenting this. Thank you.
I would.
Thank you. No, in some calculators, what I got here, actually, it's exactly that, right? I would have never thought of saying what this is, right? So this is whatever times 10, this is not the E, times 10 to negative 4.
Okay.
So then we take negative 4, with 4 decimals, 1, 2, 3, 4. 1, 2, 3 zeros and 1. Ah. Okay? Very good question. Thank you. Anything else that you encountered? Anything else that you want to look at? Is this clear now? So that only means it's not the E, the base of a log or exponential. It's this. Very good. Any questions?
That's actually chemistry class. That's no wonder why it was so bad.
Becca, is this okay? Other questions here? Do we have anything else to look at? Not right now? Okay. Good. So we continue with 6.1. In 6.1, I have the choice of presenting one method, and I always choose Gauss-Jordan. So we know 2 methods, or actually even 3. We can graph, right? We can use substitution, we can use elimination, and this is the third one. But this one is illustrated with 3 or more. I'm fine with 3. 3 equations, 3 variables. So Gauss, yes. I even rebooted twice to make sure that I got rid of the previous ones. I had a glitch again. Gauss-Jordan method of solving 3 by 3s, which means a system, of course, solving a system of 3 by 3. 3 linear, these are only linear equations in 3 variables. We have not worked on problems with 3 by 3 with substitution and elimination. No, we can. It's not a big deal. But this is the method that is required for whatever you're doing next. Not sure what it is, but this is the method that is required. However, if you read the book, or you go to the math lab, or watch a video online, and you decide to use Gaussian elimination instead of Gauss-Jordan, I'm fine. What's the difference? Gaussian elimination is half of Gauss-Jordan. So I want to go all the way and finish the whole method. If you want to stop in the middle and use Gaussian elimination from that point on, you can. I will accept it and you'll have the same credit. However, I think that once you understand this method, there is no need to even think of Gaussian elimination, but it's up to you. If you find it easier, if you read the book or you will practice with something, but I will never ask you to do this. Okay? Now, the first problem that we are going to work on today will take 40 minutes or maybe more, because I have a lot to say about the method. But then the next one will take 10 minutes, and the next one will take 5, and the next one will probably take 3. Okay, but the first one, it's a lot. Because I either can't talk fast enough, or it's a lot to present, or both. Okay, ready? I'm going to copy a system. So again, let me show you where we are. We finished chapter 4. We finished chapter 5 with 5.1, 5.4, and 5.5. Now we're going to look at 6.1, and we'll take at least the entire day and probably some of Monday to practice some more, and then 8.1, and then we can start reviewing for the test. Okay? and then the final. Okay, so we're going to pick an example or a problem, a system. If you'd like to pick, I'm more than happy. Section 6.1 starts on page 631. I'm going to copy 22. X minus 2y minus z equals 2. 2x minus y plus z equals 4. Negative x plus y minus 2z equals negative 4. As you see, this is a system with 3 linear equations in 3 variables. We've not seen anything like this before. All our systems were 2 by 2, right? 2 equations, either linear or not, non-linear, but 2 variables, correct? Okay. We have, before we even address this, we have a lot to talk about the preliminaries. First of all, I would like to show you what a matrix is. Matrices are denoted by mostly uppercase letters, but sometimes lowercase letters. We use to present a matrix, we use big brackets. And let's say I have 2, 1, 4, 3, negative 1, 4. And this is a matrix with 3 rows and 2 columns called 3 by 2. Here's another one. 1, 2, 3. Oh, this is a matrix of 3 by 1. 3 rows, 1 column. And also let's look at one more. So these are examples of matrices. So a matrix is an array of numbers. So here's another. This is a square matrix. And what will be its rank, we say? 3 by 3. Perfect. Okay, so now for now we know what a matrix is. Step number 2. The coefficient matrix. Okay, what is that? We go back now to our system. We will denote this by A. And we'll make sure that x is below x, y below y, z below z, equal symbol below the equal symbol, and the free term below the free term, which is the case here. And then I copy the coefficients 1, 2, negative 1. I copy negative 2, negative 1, 1. And I copy negative 1, 1, negative 2. And this is the coefficient matrix of this particular system. It consists of coefficients of the variables presented in the correct order. This column represents coefficients of x, coefficients of y, coefficients of z. Also, the system has what is called a column of free terms. That one will be denoted by a lowercase b, and it will consist of 2, 4, and negative 4. Okay, as an example, let me go to step 3 and then I'll ask you. Step 3, the augmented matrix. The augmented matrix consists of these two augmented together, like this. A vertical bar, B. So now it will be the same thing, a vertical bar, and now I copy. 1, negative 2, negative 1, 2, negative 1, 1, negative 1, 1, negative 2, 2, 4, negative 4. So now the question is, what does this represent? Exactly, the system. Exactly, here it is. X minus 2y minus z equals 2. 2x minus y plus z equals 4. negative x plus y minus 2z equals negative 4. That's exactly what it represents. What if I give you as an example? That was my next question. And then I'll come back to number 4. What if I give you as an example this? What do you think this is?
X plus 2. Or
To
X
what?
plus 2y equals 3. Negative 4x plus 2y.
That's it. So, of course, we're not going to look at a 2 by 2. We're going to look at a 3 by 3. So this is the augmented matrix, augmented with the column of the free terms. Okay. Step number 4. What is the target? So I don't know how everyone thinks, but you catch my interest if you told me where I'm going. So I want to tell you where we're going and then slowly get there. So what is the purpose? Okay, I have a system. Yes, I have an augmented matrix. So what? What am I trying to do? Here's what I'm trying to do. I'm trying to change the augmented matrix. Which one? This one, of course, our system. I'm trying to change it into steps to follow, but I'm trying to change it into this. As I'm giving some examples here. So if I manage to change the augmented matrix through whatever steps into this, can anyone give us X? Can anyone give us B? Y?
B.
Can anyone give us Z? But the question is, how do I get from there to here? And that's the Gauss-Jordan method. Okay? So this is our target. We want to start with the augmented matrix, and we want to eliminate everything except the main column. So then we can say X must be this, Y must be this, Z must be this, because everything else is gone. So that was our target. Step number 5. What operations are allowed? Only 3 operations are allowed. And we have to stay within those 3 operations. From the augmented matrix, or the operations we can apply on the augmented matrix are only 3. We can't invent anything. So that's step 5. Here they are. I'm going back to, I haven't even started and I wrote 4 pages. Okay, so let's look at the augmented matrix. We know it represents the system. So here's what I would like to do. For whatever reason, I want to move this row here and move this row here. Will that affect the final solution? If I consider the first condition the third one, and I move the third condition to be the first, will that change the final solution? Of course not. So that's our first allowed operation. Swap rows. Swap rows. And I know I swap conditions or equations, right? Okay. When we solved using elimination, if you remember, at times we multiplied both sides of an equation by 2 or negative 5. Or we divided both sides of an equation by 3. Right? Same thing here. We can multiply any row or divide any row by a non-zero number. Which makes sense. It's an equation, right? So multiply or divide rows by non-zero numbers. I cannot multiply by 0, I cannot divide by 0. But if I need to, I can divide or multiply by 5 or divide by 3. Last one. For the last one, we have to go back to the previous lecture. Not the last one, but the one before that. This one. And I'm looking for a system that we solved using elimination. That's it. Okay. So we had this system, and we decided to eliminate y. So what did we do? We selected the correct number. We multiplied the first equation by 7, and we took each and every term and we added it to the second equation to create a new one. Same thing here. It will look totally differently, but this is what we're going to do. We're going to multiply both sides or an entire row by 7 and add corresponding terms to create a new row. Like we did here. We created a new row or a new equation. It's right here. This one. Multiplying both sides of the first one by 7 and adding correspondingly, we created a new equation. So that's what we need. And that's the last allowed operation. Multiply a row. Sorry about that. Multiply a row, thank you, by a non, of course, zero number and add the result to another row. It looks complicated, but we are doing exactly what we've done last week with elimination. Okay, so let's summarize. I've been talking for 25 minutes and I didn't do anything. Okay, so we are looking at a system. I don't have them in order now. Okay, so we have a system. We know what a matrix is. We know what the coefficient matrix is. We know what the column matrix is. We know what the augmented matrix is. Finally, we know that what is the target. We are trying to change this into that. Then we know that we are only allowed to do these three things. Swap rows if we need to, divide or multiply rows by a non-zero number, and then multiply or divide, of course, a row by a non-zero number and add the result to another row, like in the elimination. Okay, I still have another step. Step 6. In step 6 is the mandatory sequence of steps. If you deviate from these steps, you will not solve. So this is the mandatory sequence of steps. So we want the augmented matrix to look like this. This is what we want. And the sequence of steps must be this, and no one can change it. This is the very first step, meaning I have to get the 1 in the upper first row, first column. This is the second step. I will be using the 1 to get the corresponding zeros. This is the third step. I will create the 1 in the middle of column 2. Now, of course, using that 1, I will determine the corresponding zeros in column 2. Where do you think, which one do you think is step number 5?
2 zeros.
I cannot create the zeros before I create the 1. With the help of the 1, I get the zeros. With the help of the 1, I get the zeros. Indeed. So that will be the 5th step, and this will be the 6th step. You cannot change the order in any way, shape, or form. Don't try. So 1 and the corresponding zeros, 1 in the middle and the corresponding zeros, and 1 at the bottom and the corresponding zeros. Now we do have everything that we need to start. So now, of course, I will have to copy the matrix again, the augmented matrix. Where is it? Right here. Okay. We cannot put equal symbol between matrices. We can only write an arrow. They're not equal. Okay, so I'm very happy because the first step is already done. The first row, first column already has the 1 that I need. I will need to perform some operations with row 1, multiplying row 1 by something and adding into row 2, and the same row 1 and adding into row 3. What do I multiply this row, specifically this number, and add it here to get a 0? Of course. What do I multiply this row? I cannot just multiply the first number, but the whole row by to add it to the -1 and get the 0. Nothing means 1. Correct.
Yeah.
Correct. Absolutely. I agree. Nothing in this case means 1. Perfect. Good. Do not write the equal symbol. These are not equal. Is it? Really?
I don't
Talk
know,
about
every day.
to talk about how to change silver nitrate into separate it to 2 distinct compounds, in which is done by using never mind. You guys didn't come for chemistry. How's that?
You remind me of someone who would say, one of my professors ever, he would start writing, he wouldn't remember how to continue. He would say, from here on is messy, you do it.
Well, it's not messy. You just put a copper wire and then it separates the 2.
I mean, what does that mean? Okay, never mind. Good.
Well, I mean,
So
I mean,
the row that we are multiplying has to be copied. That row is the only one that will not change at this step. So the row we multiply by, -2, etc., has to be copied immediately. So let's do this together, please. 1 times -2 plus 2. Excellent. -2 times -2 minus 1. -1 times -2 plus 1. 2 times -2 plus 4.
0.
Excellent. 1 times 1 minus 1. -2 times 1 plus 1. -1 times 1 minus 2. 2 times 1 minus 4. Yes. What have we accomplished? A lot.
So, can you go over that order again?
Yes.
Yeah, that is.
Yes. So we copied the first row because this is the row that we multiply to eliminate the 2, and we multiply to eliminate the -1. So 1 times -2 plus 2 is 0. And we move on to the next one. -2 times -2 is 4, minus 1 is 3. -1 times -2 is +2, and plus 1 is 3.
So you're doing section table 4, but
That's
just all in one.
That's what we do. Exactly. So I multiply and at the same time add to the corresponding one. So it's elimination done in one step instead of 2. So I'm not showing that I'm multiplying And I'm not showing that I'm adding. I'm doing it condensed, multiplying and adding at the same time. That's all it is. That's why I went back to the previous lecture, to show you what really happens. Okay, let's finish it one more time. So -1 times -2 is 2 plus 1 is 3. 2 times -2 is -4 plus 4 is 0. 1 times 1 minus 1 is 0. -2 times 1 plus 1 is -1. -1 times 1 is -1 minus 2 is -3. And then +2 minus 4 is -2. So this is already accomplished. Where am I now? Yes, please, Krista?
My brain's kind of lying. Where did the -2 and the 1? How did you find that?
Which one? This one?
Yeah.
Exactly what we did with the elimination, right? So we need to multiply this by -2 to add here and get 0. That's what we did with elimination, right? So the same thing here. In this particular case, I don't have to do anything. I just have to add them to get the 0 here. But in this case here, I have to multiply by -2 to add to 2 to get the 0.
Okay, I got it.
Yes?
So you just multiply a number that will multiply and add. So equal to 0, right?
Because this is the sequence. Once I have the 1, I have to get the zeros. Then when I have the 1, I have to get the zeros. And when I have the 1, I have to get the zeros.
If you don't get the zeros, then you're like,
Say it again.
Screwed.
if you don't get the zeros, then you know you're doing something wrong.
No, that's not a mistake. I mean, you have to multiply by something to get the 0. So you're not going to have the situation in which you cannot find something to multiply to get the 0. That's not going to happen. This is just the first example. I know it's long and it takes a while. But after we finish the first example, you're going to understand the method much better when we look at the second one. So we finished the first column. Where am I now and what am I doing next?
We have to solve the second column, or get the 1. Yeah.
Exactly. What should I do to get the 1 in there? Well, obviously divide row 2 by 3. I mean, it's clear. Remember, these rows are equations, right? So we divide the second row by 3. So row 2 divided by 3. So let's write. So 1, -2, -1, 2, 0, 1, 1, 0, 0, -1, -3, -2. So I accomplished what I wanted. In the next step, I have to use this number to eliminate that, and this number to eliminate this. So which row will I use now that will not change? Yes. Row 2 needs to be multiplied by something. So we can get rid of the -2 and the -1. Yes, the top one needs a 2. Very good. And this one needs a 1 again. Very good. Awesome.
So, from the dividing row 2, you get down to the bottom matrix. But we're
Yes.
not done because we didn't get the zeros. So it's kind of like a 2-step.
Yes. So I needed the 1 first. If I don't have the 1, I cannot determine the zeros. So the 1 will always help me to get the zeros. That's why the 1 of the column is always first. Top 1 first, and then the corresponding zeros, then 1 and corresponding zeros, and then 1 and corresponding zeros. That particular 1 will always help us get the corresponding zeros of the column. Is that better?
I don't know why, but I'm not picking this up.
Oh, well, in the second example, you will.
I have a question.
Yes, of course.
So the next matrix we're about to write doing that, the first column's gonna change?
Never.
It's not gonna change?
That's why I said it's done, it's carved in stone. If you do something that changes the first column, you know you're not on the right track. Very good question, thank you. Yes, that's why I circled and I said it's done and we don't look at it again, yes.
Which numbers did you divide by 3?
The entire equation,
So the number -2 and -1 you divided by,
the entire second equation.
can you pull it down?
The entire second equation, row 2 divided by 3. 0 divided by 3, 0, 3 divided by 3, 3 divided by 3, 0 divided by 3.
I'm thinking of the top one.
No, it says row 2.
Okay.
Row 2. Okay, very good. So then, now carefully, tell me what to write. Which row do I have to copy? Right at this moment, it will not change. Which one? We are using a row. Which row are we using? The one that we are using cannot change right now. Exactly. So 0, 1, 1, and 0. And of course, I copy this. I don't dare to change that, ever. If something changes it, it's terribly wrong. So 1 times 2 minus 2. Excellent. 1 times 2 minus 1. Very good. 0 times 2 plus 2. That's it. 1 times 1 minus 1. 1 times 1 minus 3. Perfect. 0 times 1 minus 2. Done. What is my next step and where am I now? Both sides of the third row or the third equation by? Exactly. Row 3 divided by negative 2. 0, 0, 1, 1. 0, 1, 1, 0, 1, 0, 1, 2. Done.
Remember, she said this 2 weeks to do this.
Which row do we use now? Yes. And what we multiply it by to add to row 1 and to add to row 2 later. Of course, in both cases. This is the final step. This will give us the answer. I copy 1, 0, 0, 1, 0, 0, 1, and 1. Ready? 1 times negative 1 plus 1. 1 times negative 1 plus 2. Perfect. 1 times negative 1 plus 1. 1 times negative 1 plus 0. What is your hope? That the solution has the following triple. Do I know that? It's so easy to make a mistake. I have no guarantee. I have to go back to the original problem and check. So, but what do we hope? We hope,
Doesn't know.
1, negative 1.
with a question mark, I have no idea. And this is Gauss-Jordan. Okay, so I go back. Yes, I know, like 4 pages, 5 pages back. Let me see where I'm at. I'm here. 1, negative 1, 1. 1, negative 1, 1, 1, negative 1, 1, 1, negative 1, 1. 1 plus 2 is 3, minus 1 is 2. 2 plus 1 is 3, plus 1 is 4. Negative 1 minus 1 is negative 2, minus 2 is negative 4. Only now I can say, yes. So what is basically happening here is a condensed elimination. Questions? Yes, as I mentioned, as I thought, it took us 41 minutes.
She should be a surgeon.
Thank you.
First
That was-
person actually gets the time right.
That's, I have to tell you, that was always my dream. But it's a long story why it didn't happen for me.
Hands aren't that bad. It's just you gotta know the anatomy. That's the biggest thing.
No, something happened in my life. My father died when I was 15, and everything else collapsed for a while in my life. Okay, so let's take a look at the next problem. 2, page 630. And now you are going to walk me through.
Oh Lord.
So this is 3x minus 2y plus 5z equals 31, and x plus 3y minus 3z equals negative 12, and then negative 2x minus 5y plus 3z equals 11. It's not that I don't like what I do. I enjoy what I do very much. But that was my dream from a long time. Okay. Make sure that terms with x are below terms with x, y, z, equal symbol, free term. Since they are, we don't have to rearrange anything. We are going to immediately start with the augmented matrix. Can anyone dictate? Now you can say, wait a minute, I don't really want to write it right now. I want to swap already, so I don't have to write it twice. What will you swap if you think of that?
Middleton tap.
Yes, because that is the one that I need here at the top, and this one has it, this one doesn't. So I'm going to change the order of the equations. I'm going to put 1, 3, -3, -12 first, and I'm going to put 3, yes, -2, 5, and 31, and -2, -5, 3, and 11. Why? Because I already have what I wanted. I need to start with that. Any questions so far? Okay, which row do we start multiplying by? We don't even look at what it is, but which row? Yes, of course. So I have to start with row 1. So one more time, Garrett, is that clear? The augmented matrix, is that clear?
Yeah,
Okay.
yeah, that part's the.
Is it clear why we have to start with the 1 at the top?
So you can multiply by 1 for the next step.
Exactly. Good. What should we multiply? Let Garrett answer this one. What should we multiply this row to eliminate this?
-30.
Of course. What should we multiply this row to eliminate this number?
2.
That's it. That's all we need to do. Which row do I have to copy because I'm using it, and since I'm using it, it cannot change at this point.
First one.
Right. So 1, 3, -3, -12. Okay. Now, slowly tell me what to write. Yes, because it's 1 times -3 plus 3. Is that okay? So 3 times -3, -9, plus -2, -11. This product plus 5. Do we all agree with 14? So this will be 36 plus 31.
67.
Excellent. Is this clear now? Feeling better?
Little bit.
Okay. Yeah.
Little bit.
It's not a big deal. You're just gonna. It's a sequence of steps. It's repetitive. It's not a big deal. But I need 40 minutes to present step by step what it involves. I just couldn't go directly
I just
to
need more
start
practice.
multiplying this, right? You understand that we had to go through matrix, augmented matrix, and the procedure and what happens and what the operations are and where we're going to. Yeah. Good. So the next one, please. Yes. Very good. Yes, because this is, careful, -6 plus 3. -24 plus 11. Done. If somehow the first column changes, you are not on the right track and you are not proceeding according to the mandatory sequence. If you are proceeding according to the mandatory sequence, you will never destroy the first column. Yes?
I wanna know, but I can get next to
Yes, please.
swap it again.
Of course. You cannot swap with the first one, however, right? We don't even want to. But once you finish this column, if you swap these two, it'll be a tragedy. You'll have 0 at the top and 1 here. Of course, I know what you meant. Of course, I'm just saying, yes. We have to swap those two. That's the easiest thing to do. Otherwise, you will have to divide by -11. Do you want to divide this by -11?
No.
No. So then I'm going to have to write all steps have to be written on the side. Row 2 becomes row 3, and row 3 becomes row 2. This is what I did in the next step, or what I'm going to do in the next step. So then 1, 3, negative 3, negative 12, 0, 1, negative 3, negative 13, 0, negative 11, 14, 67. So this is all done, but now this is done. That's why you suggested to swap, because it was the easiest thing to do to get the 1 in the middle. Now I need to determine the zeros corresponding, using that 1, the zeros corresponding to that column. So I want this to change into a 0, and I want this to change into a 0. Which row, this is our second step basically, which row will I use now? Of course, because I'm using the 1. Right. So row 2 times something plus row 1, and row 2 times something plus row 3. Once you understand the pattern and stick with the sequence, it's really nothing sophisticated. Okay, but that's Gauss-Jordan. Okay, so what do we multiply this by to eliminate that? Agreed? What do we multiply by to get rid of this? Good. Which row do I copy? I'm using it, it can change. And of course the column. Perfect. So, perfect. So, awesome. So positive 9 minus 3 is 6. Positive 39 and minus 12.
27.
1 times 11 minus 11. Negative 3 times 11. That is negative 33, and 14 is 19. Negative 13 times 11. It's minus, and 67. Hold on. Right? So I have to subtract from 143. I subtract 67, and I get a negative number, right? Is it 86? No, this is negative, this is positive.
Shouldn't it be
So it has to be a negative number. So 6,
76?
6 from 13, 76. Thank you.
Big numbers.
Done. Where am I now? So I have to divide both sides. In other words, I divide the third row by negative 19. So row 3 gets divided by negative 19. One 0 6 27 0 1 negative 3 negative 13 0 0 1 4.
Wait, what? Where's the 4?
Negative 19 divided by negative 19, negative 76 divided by negative 19. This is what we're doing. We're dividing row 3 by negative 19. So now this is all done. Final step. We want zeros here. Which row do I have to use in the last step? I have no choice. Yes, of course, row 3. What do I need to multiply row 3 by to eliminate the 6? Good. What do I need to multiply row 3 by to eliminate the negative 3? And this is the final step. Done. One times negative 6 plus 6. 4 times negative 6
24.
plus 27. Excellent. See, told you. 1 times 3 minus 3. 4 times 3.
7.
Careful.
Sorry, 12.
12 minus 13. Okay. What is our hope? And I want to tell you this.
Brain math.
If and when I make an error, very possible, I put everything aside and start from scratch. It's so difficult to start to look and try to find the mistake and correct it. And so our hope is, do we understand this? Okay, so now I go back. 3, negative 1, 4. I don't know. We'll see. 9 plus 2, 11. 11 plus 20, 31. 3 minus 3, 0. Negative 3 times 4, negative 12. Negative 6 plus 5 is negative 1. 12 minus 1, 11. Yes.
Can I make a system, like, just trying a bunch of, like, I'm trying to memorize this, but I'm trying to also think of, like, plan A, B, and C. You know, I'm thinking of this, like, you said there's a second